Alright, welcome back. This week we'll have two videos. I found another box of motors that I'd like to test, so some of these might actually end up on the robot. In this video we'll be exploring some little motors I found. Some are gear motors, some are just straight motors, and we'll experiment with the motor speed controller that we used earlier when I tested those fans. Should be good. No smoke, promise. These two will be the last videos for 2022. I realize these ones ran really long. For next year, I'll be experimenting with a much shorter format. I'm going to do the next continuation here. I've got some of my test stuff out again, so the motor speed controller I'm using for testing some of the motors. I got the battery and the switch. This is one of the broken radio-controlled buggies I've got. I bought 3 or 4 at the same time, mainly just because if I'm making something, I needed matching wheels and matching parts, and these were really cheap on eBay, I think, probably eBay. And I thought, well, let me just get 4 at the same time, because if you like it, you can't go back and find it again. That's the biggest problem. So I got several matching. One that I set up for testing with, it's got the camera mount on it, which turned out not to work very well. These have motors in the bottom, and it's I don't know if it's a true differential, but it's at least a gear drive that splits it out to the 2 motors. And on the front, it actually steers, obviously, because it wouldn't make much sense if it didn't. But these are 4-wheel drive. So the motor is driving through a shaft out to the wheels on here, which is pretty clever. And the center of the wheel has a kind of a hexagonal shape to it. Take one apart, because it's like, this is kind of neat how they set it up. With the suspension and everything, this whole back half moves separate from the body. All right. They had springs on here. They had little shock absorbers. So I had a couple broken shocks on the other rover. So I took them all apart and made one good one out of several broken ones, kind of thing. This is one of those rare things that you buy that they put screws everywhere, so you could actually take it apart. Whereas most things you buy are snapped together, can't be taken apart without destroying them. You know, this is actually, I mean, look at all the screws. It's like there is screws for everything. You can just take it down to its littlest parts. You know, the radio control part here and the motor drivers, they didn't cover it up with epoxy. You can actually see what's in there. You know, not really super high quality, but nicely made. You know, so some useful parts here. I've got 2 grinders that are broken, so I've replaced them. But I saved the parts, and I was curious about how the gears work in here. Because I was talking about on the windshield wiper motor, they used a gear drive. I don't think these are gear drive, worm drive, I should say. I think they're bevel drive. But it's set up about 3-to-1. I counted it. So if I look at the tape here, and there's a dot right there. There's like, for the wrench, to get the grinder wheel off, there's 4 holes, so I put a dot on there. So if we go around once, twice, 3 times, pretty close 3-to-1. Okay, so the motor turns 3 times for every 1 turn of the wheel. Okay, these are like $20 a piece. They're really cheap grinders. Okay, they got bearings on the top. I'm not sure what part of this actually wore out. I can't remember, but I had 2 of them quit working almost at the same time. All right. I usually have more than 1 grinder at the same time while I'm working, because it's nice to have one to do the cutting. You put the thin cutoff wheel. One to do grinding, like if you want to clean up your welds. You could put a wire wheel on one. You could put a flat brush on one, you know, that kind of thing. So rather than stopping to change the wheel constantly, you just grab the other grinder. You know, that's kind of how it is. If you got set up to do something, it's just easier that way. Anyway, so I don't remember exactly what the failure was on this, but it does feel like it's basically working. Well, what we need is to go slower. Okay. An electric motor turns way too fast for whatever you're driving usually. Like a fan, okay, you'd run that straight through 1-to-1 probably. But a lot of things, you would want the wheel to turn slower than the motor. It's like if you're in the car, you go in first gear when you're getting going, then eventually you might up in, overdrive, where your wheels are actually turning faster than your motor is. But you can't start that way. You need to start off slow. Okay. Same kind of thing here. The motors we have, the littlest motors, probably turn 10,000 RPMs. And I want the wheel to turn about 100 RPMs, really, would be about right, maybe even slower. So that's kind of the challenge, is to set gearing up so the motor turns at a speed that it's designed for, and you get the wheel slowed down enough. So we'll be taking some of these things apart and playing around with them a little bit. And for a 6-wheel robot, here's the hard part. The 6-wheel robot, whatever I come up with, I have to duplicate 6 times. Well, if I use the grinder as a starting point at $20 times 6, that's $120 right there. Okay. It would probably work though. Now for the first one for testing, that's more than I want to spend. If I end up selling this robot commercially for $3,000, I don't mind going and buying 6 grinders from Harbor Freight and taking them apart and putting this gearbox on. That would be hilarious. Plus I'd have a leftover motor for something else. Okay. There may be things that I test out of plastic, and then later on when I find a part that I like, I can go to a place like McMaster Car or other places like that and go buy exactly the right part that's machine made, properly made, will last forever. If it's part of a project that I'm going to sell, I could afford to then go buy good parts. But for right now, I don't have the cash to go buy a lot of different things to test them. So we got a shot of the grinder earlier. I just want to use this for an example for maybe how to set up a gear. So the motor would be normally here, and then it does a 90-degree, probably a bevel gear. We'll take it apart and find out. And then the output is here. So this is where your grinder wheel would go. Okay. Different grinders might have different gear ratios. Okay. Speaking of gears, this one I think I got from Spark Fun. It's just a little gear motor. So the motor is here, the silver part, and then the gears are in the yellow part. This one is labeled 48-to-1. So the motor could turn nearly 50 turns, 48, for 1 turn of the output shaft. That's getting better. Okay. Then we've got this one. This is 160 RPM, and so they didn't tell me the ratio, but the output shaft will turn 160 turns in a minute, 160 RPM, and it's a 12-volt motor, and it's in a metal case, which makes it, probably a lot better. We'll see. We could also later look up the specs on this motor. Probably it's a 12. Looks like 1280. I'm not sure what that means, but I've seen a bunch of motors with ratings like that. So if I liked parts of this, I could maybe get the motor and keep the gears from this one and switch it over or something like that. Okay, that's kind of that's one of the ideas. This is the guts from one of the buggies. That would be this one. You've maybe seen that. This is going to end up on the Mars Clipper channel, but on the main Carlin Com, my main channel, I did some testing with this earlier. And then a later project, I wanted to see if I liked it better with bigger wheels, and without spending a bunch of time, I just took the lids off of some mixed nut containers and glued them with hot glue right onto the sides of the tires. And that worked ridiculously well. I mean, it didn't break while I was using it. I knocked it off the shelf and then it broke. But it was running up and down the driveway just fine. All right. You can see the battery on the side. This thing came with its own proprietary little, I think it was a NiCad battery pack that had a special charger. And I was looking at that. I'm like, you know what? I bet this would work better if I upgraded the battery. So I put a single 18650 that runs at 4.2 volts. And this was made to run on about a 5-volt battery. And this completely transformed this. I mean, it works 100 times better with this single battery on here. And it's set up to USB charge, so I can just plug it into a USB port, charge the battery up. And then I did the same thing with the controller. This is what it came with. I took the controller apart, added, I'll look these up later. Maybe I'll put it up on screen if I find it again. But you can buy these. They're just a few cents a piece. It's got a USB port on the input, and it hooks up. It's made to charge that battery. You know, so you just go buy them eBay. They come, you know, right out of China. Super cheap. Works really good. Just plug it into a USB port. A little while later, the red light turns green, and you know it's charged, and then you unplug it, and away you go. Yeah, keeps it simple. So my reason for this was I was going to take this on the bicycle trip. This is a GoPro mount. What I wanted to do was to be able to drive the camera, essentially, 100 feet away, park it, and then ride the bicycle past it. So you get that shot of riding past the camera. Usually to do that, you would then have to stop and walk back and get the camera. Yeah, I thought, well, if I put it on the car, I could stop at the side of the road, pull out the remote control that I would have on the handlebar somewhere, and drive the car up to where I was, reach down, pick it up, stick it on the bike somewhere, and then take off, right? So that's one of the things that I want to do. This one, it turned out, was just too small. Even on, you know, relatively smooth gravel out here, it'd just be bouncing like crazy, and the camera, you know, was just flailing itself. The GoPro did okay, but it just wasn't good enough, right? I'm like, okay, I'm going to have to do something better. So that's one of the things I want the robot to be able to do, is to be able to drive around out here, stop and pan back, and then see what we're doing. So instead of having a tripod, I could have the robot standing there, and I could point at something, and the robot would know that I'm pointing at something, and then it would point there. And then the camera would just lock into something, right? That's the dream. The more I'm learning, that is possible, okay? Okay, so this is the inside of that. I bought several of those specifically because I knew I was going to take it apart to do other projects. I have actually drove that one around just for fun, but that's not why I bought it. I bought it because it had 4 rubber tires and 4-wheel drive and a good set of parts that I could base something else on. Okay, so that's as much, you know, I didn't buy it for a toy. I bought it for important stuff. Anyway, so this is the inside. That's the back, and this is the front. This is where the steering is. But it is 4-wheel drive. Okay, so it's got a motor for the wheels, and it also had a steering mechanism. This one broke, so I took it off, or I took this one off to fix that one, probably. Anyway, so this is the wires that go down to here, and I got a couple little jumper wires. These are called DuPont wires. If you do anything with Arduinos or Raspberry Pis, you'll run into these a lot. This you can plug into a breadboard. If you don't know what a breadboard is, we'll come back to that some other time. It'll show up eventually. So what I wanted to do, could I test a variable speed controller with this motor? Okay, would that be good or bad? These cars, one of the problems is they don't really have adjustable speed or steering. It's all on or all off, which is kind of fun if you're a kid, but not very practical if you wanted to actually drive smoothly. Okay. So that's a limitation of the controller that they put in here. Not very good, really cheap, good enough kind of thing. So I want to test this with some other things, see if I could maybe upgrade the control circuit on here to put like radio control parts on it instead of the really cheap controller, put good stuff on it. So we could do a smooth acceleration and a smooth stop and that kind of thing. Okay, so we'll test that. We'll test the little one, test this one, and then a collection of alligator clip test leads. These are indispensable for this kind of experimenting. You can just clip it onto something instead of having to solder, you know, for a quick test. That's the way to go. So you don't have to sit here and try to hold the wire and see if it's working, okay? And then we've looked at this before. This is the windshield wiper motor that came out of the bus. This showed up a little bit on another video. What I was doing is I 3D printed a replica of a bicycle chain sprocket. I've got a whole bunch of bike parts, and I thought if I could do something based on this, they're incredibly strong, they're really, pretty inexpensive, it might be worth using them. The problem is I only had one of one specific size. So I thought, well, let me just see as a test, how long would it take and would it work? This one didn't quite work, but I think I could get around the issues. It was like the thickness of the sprocket is more important than I realized. The chain I was using wasn't in very good shape. It's an older chain. I didn't want to cut a brand new chain. And then I also made this adapter that holds the motor for me, because that was one of the issues is, how do you test the motor and hang on to it at the same time? So I made this little, plate, and then I had a problem with the 3D print. It split because cold air, it's getting towards winter, and so the shop or the room that the 3D printer in isn't heated, and so the cold air hit the hot part as it was printing and it split. So not ideal, but it's like, well, for some of these things you're going to use it once or twice, and then you're like, was it even worth 4 hours to print that part, or should I have done it a different way? Whatever. So we'll use it as it is. But one of the things I did not do yet, but it should work, can I do a speed control on this and actually speed it up and slow it down? And can I run the motor in reverse? It should work, but I haven't tested it yet. So this is what we used for testing. I'm just thinking, we tested the windshield defroster fans from the bus with this, and they worked okay. So I should be able to hook up the wiper motor and speed it up and slow it down and reverse the direction. Okay, so we'll do that just as a quick test. I'm not going to spend too much time with it. But I also wanted to see if I run this slowly with this wheel on it, I can, grab it gently so I don't rip the skin off my fingers and see how much torque it has and kind of get an idea. Do I even need to do gear reduction, or would this work as it is to drive a wheel? Okay, so we'll test that. But in the beginning, I can test 3 or 4 ideas and see if it works. Even if it doesn't work very well, it'll give me an idea if it's close. Then I go, spend a little bit of money, get the thing ordered. It'll take it a week to get here. In the meantime, I could test 3 or 4 versions. Okay. So I'm trying not to order things. It's like I'll wake up with an idea, get excited, pull up my phone, order a part, and a couple days later it gets here. Then I realize it's really not something I needed. Okay, that happens quite a bit. So I'm trying not to do that. Oh, just for an example, that's an Arduino. That is a little microcontroller that you can program and hook things up to it. And then it's one of the coolest things ever, honestly. I can just leave it at that. But basically, you can write software, program this, disconnect it from the computer, and then all of these, where these pins are, I'm not going to open this one, you could connect things to them. So I could hook, for instance, like this. I think you could probably do it with this one. If not, there's one like this that I have that you can do it with. Basically, I could have, okay, this one's got a potentiometer that you could use like a volume switch or a throttle. Okay. I could hook that up to the Arduino and program the Arduino with specific settings. The Arduino could also have, for instance, a temperature sensor. So it says, okay, it's getting too warm. It could turn on the fan. If it's not super warm, it would turn on the fan half speed. And then it could measure the temperature difference and see if it was working. That's the kind of things you can do with the Arduino. Very cool. So I've got more of those. Oh, here we go. This little guy in here is a little tiny motor controller that does basically the same job as this big thing. Look at how small that is. You can run 2 motors with this. So I got a few of those. That's what we're going to use on the robot. I got these from SparkFun. There's the part number, ROB14451. So it's a dual motor controller. Yeah. I bought these, and then at the last minute I decided to get some of these little plastic motors to test with. And we'll see if we use them. They might work for something. They aren't going to work for driving the robot, but they might be enough to drive the steering for the robot, is one of the ideas was. So this is the same basic setup that I had when I was testing the windshield defroster fans in the other video. We're on a different workbench, but same diff. So this is a battery pack that I made a few years ago. It's made up of 18650s, and 18650 fully charged is 4.2 volts. You take 3 of those, that gives you about 12.6 volts. So this is wired 3 in series for 12.6, and I think it's 3 parallel, and it has a BMS in it. That worked out pretty good a couple days ago when I was testing something, accidentally bumped a wire, it shorted it out, and the battery pack just shut itself off, which a normal battery would sit there and smoke and spark and you have all kinds of problems. The battery just shuts itself off, no big deal. You unplug it, you wait a second, you plug it back in, and it's right back and working. This is a switch that I have. It's just a basic switch, although this one is actually a breaker switch. I shouldn't say it's a basic switch. This is a very expensive switch that I happen to have sitting around. It's a breaker switch. I think these are $100, and I'm not sure if you can even buy these anymore. Came out of a truck I was working on. I ended up with a whole bunch of them. So one of those things where I wouldn't have it if I bought retail price, but since I got a box full of them, why not use them? So it's a breaker. Red is on. Hit it to turn it off. Okay. What happened last time when I accidentally shorted it out? The battery shut off faster than the breaker could pop. Okay, so it's just a convenient way to unplug it or to turn it off instead of unplugging it all the time. Okay, so battery, switch. This is a LED voltmeter, which probably doesn't show up in the sunlight. It's telling me 12.1 volts, so I just know I got power on the battery. A lot of these things, and I said this in the last video, I just happened to have them sitting around. So I had this switch that already had the connectors on it. Okay, these are XT60s, the connector. It's just a high power connector that's, you can solder it on. I use it on a bunch of stuff. So I just happen to have a battery with an XT60, a switch with an XT60, a voltmeter with an XT60, and then a handful of wire leads that also had the XT60. So it's almost like Legos. You just plug them all in. Now you got a circuit that you can test things with. When I'm done with this, I could take this off, and I've ran water pumps with this, or that kind of stuff. So I just got all these things laying around. Okay, we're going to use this motor controller for a few of the experiments today. And I'm calling these experiments because I think most of these will work, but I just kind of want to get a feeling at 12 volts, how fast is this motor? How powerful is it? Does it work? Does this motor work with this battery and this speed controller? Is that a starting point that we can be happy with? If it's completely wrong, what I want to do in my mind, I'm not going to spend a bunch of time writing this down, but I can say, okay, this motor had a lot of power, but it's not going to work for the robot, but it might work for something else. So I can put it back on the shelf, and then later on, I'll think about it. I'm like, oh, I know exactly where I want to use that. So I have all these stuff. I mean, I've got boxes of stuff. Literally thousands of dollars worth of stuff that I bought on eBay when I was living in Austin. I had a job, I was making money, I'd have retail therapy every night when I got home from work. I'd go on eBay and I'd buy stuff. And then by the time I got there, I'd forget what I was going to use it for. I'd put it in a box and put it back in the closet. And I just hung on to it all. So now, out here, I've got time to do stuff with it. So that's kind of where we're at. Okay, so this motor controller, I mentioned the Arduino. It's sort of the same idea, except it's self-contained. You can't program it, but it's got all the parts. So they gave you a variable potentiometer that's got a click switch on it. You can, when you first turn it on, it clicks. And then from minimum to maximum, and then you turn it down and off. And it's also got a switch that's got off in the middle and 1 and 2. That's not necessarily speed, it's direction. So I can reverse the motor with that. Okay. I got a red and a black coming from the battery pack through all the stuff into this thing. And then I've got 2 leads going out to the motor. We talked about that more on the other video. So if you're curious, I'll try to remember to link it. There's going to be a video that I tested these motors on. Okay. Haven't actually edited it yet, but it's been shot for a while. So this one turns pretty slow. The motor comes through this part, that's the gearbox. The motor turns pretty fast, comes through the gearbox, slows it right down. The output turns pretty slow. This is what drives your windshield wipers. This came off the bus. I got 2 of them and they both work. If I had 6, I'd be done. I'd just go build robots and use these for all 6 wheels. Since I only got 2, I'm looking at my other options. One of these on eBay new is about $25. It's the cheapest one I found. And okay, 25 times 6, that's what, 150 bucks. Okay. On top of everything else, this would be a working solution. It would work really good. Not something I want to go buy 6 of. However, I might make a robot with 2 wheels and use these on that instead for a different project. Okay. All right, so just to see if it works, now that we've got all that covered, I wanted to explain this because I'm going to use the same setup on the rest of the ones today. Okay, so switch on, and that's on position number 1. That should go in one direction, and then we will turn this on, and there it goes. It's just creeping right now. And as we turn it up, okay, that's normal speed. That's actually the high speed, I think. Turn it off. There's 2 connectors on this motor. I think that was high speed, so let's turn it down to the low speed and just see if there's a difference. I mean, there is a difference, but okay, back on 1. Yeah, so I've got a high and low connector on here, the same way as the fans, actually. The fans had 2 wires you could connect, one for fast and one for slow. This has got the same kind of a thing, okay? So when this is going slow, that's halfway on the dial here, right? I literally can't stop that without hurting myself. So this would work really good on a motor. I mean, on a wheel. I could drive a wheel with that and be completely fine, which is kind of cool. Yeah, that would definitely show up. So this is just putting along on the low setting and halfway up on the throttle. And it works just completely fine. So at the moment, it's turning this way, just in case that doesn't show up. I think it does, though. So from this point, it's clockwise. I think that'll show up a little better. Good, yeah, that shows up. So I can just turn it off, and then I'll go in reverse. Sounds a little bit different going backwards. This one has, I think a lot of these motors, they will run backwards, but they weren't made to run backwards. So they would have optimized it to run one direction because your wipers don't have a reverse mode on them. You see them going back and forth, but that's because of the gear drive, which is on the other video. The motor itself doesn't back up. It just goes to the next cycle and stops. Okay, so this one works pretty good forward, not maybe quite as good backwards. So let's go faster. Okay, that's forward and then stop. I want to see if it sounds better going faster backwards. That sounds okay going backwards, so just when it's going really slow, it didn't like it. Even going slow, you really can't stop it. It'll just keep going. Cool, okay. That's all I wanted to do with this, to see if it worked backwards, and it does, so we can stop there. So I'm going to turn my switch off just so I don't short something out. And then we'll disconnect this, and then we'll come back with the next one. Okay, everything is the same. We just swapped out that little tiny motor. I put a little piece of tape on the motor so you can see it. I am using a red and black wire. And instead of hooking up the screw terminals, I just used the alligator clips, same as these. You squeeze them and they open. I got a couple bigger ones. And I just clipped them right over the top of the screw terminals on the speed controller. Quick and easy. Works good enough for now. So now that we're hooked up, I can turn the switch on. Make sure this is all the way down, and then we'll turn it on. And I don't remember the spec on these motors. I got a whole pile of them. I could look it up. I think I tested it earlier with 12 volts and it seemed okay. If I run it slow, it'll last longer though. So we'll just kind of turn it on. Hear the click. Okay, it's going really slow. It's almost faster than you can see it. That's one of the things I'm looking at. If I go to use this, I'm going to need to slow it down at least 100 to 1 to be useful. Okay, so that's going, in this case, it's going counterclockwise. If I switch these red and black leads, it would go backwards. Okay. So for instance, like I was saying on the other video, if I hooked this all up in the robot and realized it was going the wrong way, I could just switch the leads, or I could switch the motor controller. But if I had a bunch of stuff I didn't want to mess with it, I could just switch the leads. It'd be easier. Okay, so this is going counterclockwise. Switch it off. Okay, now it's going clockwise, but it's not moving. Just give it a little more power. This is like I was saying before, some of these motors might have a preference to what direction they're turning, so it would work one way but not the other. Or it just takes a little bit to get it going. Once it's going, now it goes either way. So it might have a starting problem. If it's going too slow, it just won't start. So you'd have to hit the throttle a little bit. But once it's going, it's fine. Okay, so let's see how fast it'll go. Since I've got a bunch of these, I don't, if I blow up one, it's not a big deal. That's about, there's half. Like the other one, I just wanted to see how much torque this has when it's going slow, if I could stop it or not. So what I'm going to do is figure out a speed that it'll run at. Okay, I'll just go by hearing it now. Okay, so we are maybe 1/3 throttle. Okay, I can stop that one at 1/3. It's just a little tiny motor. At half throttle, I can stop it, but barely. And that's just fingers grabbing the shaft. It's a smooth shaft. That won't rip my skin off the way that the windshield wiper motor would. Okay, but it does work. Okay, so that's that one. Shut the switch off. Now that I got these out, I can use them for testing the other motors. I've seen this done so many different ways, and it's always like everybody comes up with the same idea. We must all be copying one person somewhere, putting a piece of tape on the end so you can see it moving. Seems kind of funny. There's little wire connectors up on here that you clip onto. So let's see if we can hit them. They're so small, the alligator clip is going to rip it off. That would be sad. And I do not remember what the rating is on this. Let me look at the other. Actually, in this box, I've got the instructions that these came with. Oh, this is labeled as 140 RPM at 48 to 1. So this one will run nearly as fast as this one. This one will just have a lot more power. We'll start off small and hopefully we don't kill it. Now, can we see that? Yep, okay. So we will turn it, switch on, direction on, turn on. Okay. So we can have it going. You can hear it, the little gears are making noise in there. Doesn't sound bad going at full 12 volts though, so that's promising. So at half speed, I'll do the same thing, see if I can stop it or not. Oh man, that's got a lot of torque. Oops, just knocked the wires off. Okay, it was working though. Right up until it wasn't. Oh, I probably didn't see if it went backwards, so let's try that real quick. Yeah, it had enough torque. Okay, that's going one way. That's going the other way. Okay, so it's going both directions. Cool. Okay. Shut that off so we don't blow it up. So that works. It actually had a reasonable amount of torque. I think one of the things I'm looking at, could I have this driving through something like this to go from a small pulley up to a big pulley and then actually drive a wheel? Now, it wouldn't pull the whole robot all the way across the desert, but it might be enough to move it around for testing. Okay, because I've got 4 of these. That's a start. And they weren't very much money. Okay, so we'll keep that in mind. And it looks like I can take these apart, so we can open it up and see how many gears are inside and maybe try to copy the design, make a bigger version of it. Okay, always an idea. So the yellow ones worked good, had a good amount of torque. I was pretty happy. So the same thing here, that flag isn't very big, but it should work. So we'll set that there. They did label red and black, so we'll go ahead and follow that. But like I was saying before, most of the motors you could run backwards. If you do have a mark like a red and a black, at least then you could get them all going the right direction. Try to get this in the shot. Yeah, that'll show up. Okay, switch on. Turn it on, turn it on. Okay, that's full throttle. I think it was it labeled 140 or 160? 160 RPM. So if it was 120, it's 2 revolutions per second. That seems about right. Okay. So I'll try it again. I know I'm not going to be able to stop this one. So half throttle. No. I mean, if I really cranked on it, I could stop it, but if that was hooked up to a wheel, I mean, that would be interesting. See if I could have it pull me around. Maybe it would. Okay, and then try backwards. Yep, no problem going backwards. So the yellow one and this one have a similar setup on the gear drives, only they are facing opposite directions. So this comes in this way and then it's turning this way. So at some point they probably have a bevel gear, probably similar to how the grinder works. That's working great. But yeah, full speed. You can see it jumping around, how much torque it's got when you stop it. Nice and quiet too. I probably bought these years ago. I have no idea. You know, I could maybe go back in my old eBay listings and see if I could find it. Quite often when I would buy something, I would buy at least 2 of them in case I liked it. I wouldn't have to go back and find it again. That kind of thing. Yeah, that's one of the biggest problems. You find something you like and then you can't find it anymore. It's got a SKU number on it, so maybe I could look it up again. No idea where I got it though. I mean, just eBay. This is 12 volt in, so it's come out of here and then we can run, I'm trying to run the little fan or the little radio control car without killing it. And it's only going to run at 5 volts, so we're going to use this little step down transformer is what it is. So I'll just chop this part off. We got a switch, we can hook this up. This should still work. I'm not sure what this is going to do when it has PWM coming into it though. That might not be a good thing. Guess we can try it and see what it does, right? We'll test this in stages. So we'll take our multimeter. This is the one we had last time. I'm going to use it first. I want to see which one of these ports is actually positive, and we will only run this in one direction. So we'll just say on 1, so that it's going in the same direction, and I want to see which one is positive so I don't screw this thing up, because if I run reverse polarity that might be a problem. So I got 12 volts from the battery. I am going to turn this all the way on, and that's on 1, and I'll look on my meter, beep. I think it's going to be this way, and I am wrong, so it's this way. Okay, so red, same, so it's red, black, okay. So we'll start there. So we will take the leads from the input from this, and we will hook them up to here. That's off. There's a chance this won't work. Usually it just won't work. Sometimes it doesn't work and it lets the smoke out. So I've got 2 of these, and I don't really plan on using this on the robot, but it's kind of neat to have for testing like this. So I don't have to have a programming setup and everything. Okay, so the output of this, we'll try to keep those from hitting each other. And we left that on 1, and we left that on full, and we turn this on. So this should have 5 volts coming out, which may or may not show up. Probably won't. So black, red, let's check it here. Oh, switch. I've got a switch in line. Let's turn that on. So now we should have 12 here, just to be sure. 12 there. And then I'm seeing that right. Yep, 4.97 volts. Okay, good. So that part's working. So we will just leave all of this alone. So when I turn on the master switch, this is going to have power coming to it at full power. I want to see if it works at full power first, then we'll see if we can slow it down. And we are not going to run this in reverse because that'll mess this up. Both of these wheels should turn. We'll just put the tape on 1. Also, there's no wheel on that. How bad do I want to do that? Let's go all the way. These are kind of cool. They put a hex in the end of the wheel, so you just slip it onto the hex, and that's it. So I will just borrow our flashlight, set that up on top to keep it up off the ground, since I don't have any jack stands for this. So the plan is going to be, I will hook up my, let's see, we'll say red is yellow. These leads are smaller. I think my big red and black ones are too big. They weigh too much. They start pulling things down. Okay, so that will go to the red, which over here, I'm just hooking it up to these things I call the DuPont test leads. And then we'll hook up the other one. And that should be enough to make it work. That way I don't have to rip off the connectors that make this thing work when it's put together. Okay. So that's that. This should start running when I put power on. Let's see what we get. Trip over the giant rock. Yeah, that should work. Switch on, and that should start working. Oh yeah. Ridiculously fast. This is the problem. This thing goes too fast. If I could slow this down to like 10% of its speed, I would, right? So what I want to see, if I slow this down, this shouldn't care. It'll just stop working when it gets too slow. Okay, so that should work, I think, because this is smart enough that it'll just quit working when the battery goes dead. All right, so it shouldn't hurt it. So let's try that. Let's turn this on, and then let's start slowing this down and see what happens. I am way down before that even made a difference. Okay, this particular one, not especially effective on that. It did work a little bit, but this is probably trying its best to boost the power as it comes down to keep the 5-volt thing working. So that's not the best solution, but it did kind of work. So that does remind me how fast this thing goes, though. It's ridiculously fast. It just goes zipping around. So it's really too fast for... It's great for if you're actually trying to have a race. It's not so great when you're just trying to watch it on a camera. Like if you were... Like one of the ideas, I want to be able to drive this under the house to see if the rabbits are there, or drive it under the bus to see if that's where all the rattlesnakes are coming from, without sticking my head down there. So if I had a camera on here, I would want to go really slow, not really fast. So that's kind of the issue. Okay, so I think we tested everything we came out to test, which is kind of cool. Okay, that's it for now. Thank you so much for watching my video to the end. It really does make a difference. If you would like to help build the robot army, please be sure to like and subscribe to the videos. Also, Patreon and PayPal support is greatly appreciated. Information is down in the video description below. Okay, thanks again, and goodbye for now.